ओके हेलो एवरीवन। आज हम लोग स्टार्ट कर रहे हैं एक बहुत ही इंटरेस्टिंग टॉपिक, अ वेरी इंटरेस्टिंग टॉपिक दैट इज़ POAC method. Okay, so today we are going to discuss POAC method, and in this whole topic we will discuss what is POAC method and how we can use that method in solving numerical problems. So we are going to discuss POAC method. Okay, POAC is basically principle of atomic conservation. POAC is principle of atomic conservation. Okay, principle of atomic conservation means we will solve numerical problems by using conserving atom, and conservation of atoms indirectly also means mass conservation, and that's why we can say this method is atom conservation method or mass conservation method. Okay, so this method is basically for quantitative analysis. Quantitative analysis means where we have to deal with quantity, like sometimes question asks what is the amount of reactant when this much amount of product is formed, or it can say what is the amount of product when this much amount of reactant is reacted. So these type of problems based on quantitative analysis discuss and deal with this method. This is one of the method among several method. Okay, it is to be noted this is not the only method. And second and important thing is we don't need to balance a chemical reaction while using this method. Wow, amazing, no? We don't need to use and we don't need to balance a chemical reaction. So simple. Yes, no doubt we have to know what is the chemical reaction, but we don't need to balance a chemical reaction, because sometimes balancing a chemical reaction becomes so much tedious. Okay, so how we are going to solve a numerical problem? We will basically conserve atom while solving numerical problems. Means to say we will conserve atom on reactant side and conserve atom on product side, and this is in this article I am going to discuss how atoms conserve on reactant and product side. Okay, generally this method is used in combustion reaction method. Combustion reaction means burning in the sufficient supply of oxygen. So when some substance undergoes combustion, this method is efficient, is applied on that type of can be applied on that type of reaction. Okay, and the next important point is POAC, about POAC method. Okay, what happen generally, good, sometimes question ask what will be the chemical formula of a certain type of hydrocarbon which on combustion give this amount of reactant, give this amount of CO2 and H2O. Sometimes question say, okay, estimation of molecular formula, estimation of chemical formula of that hydrocarbon. Then for particular those type of numerical problem, this method is amazing. So don't forget to use this method if a question asks what will be the chemical formula, what will be the molecular formula. So this method is perfect. Okay, and next thing is we don't need to balance a chemical reaction, already discussed, and after write a chemical reaction we can solve numerical problems. This is basically POAC method. All points are written over here. Okay, now let's understand exactly what is this method. So before discuss this topic in detail, I will discuss one a simple example with you. Okay, a very simple example. Imagine I have one molecule of H2SO4. What I have? One molecule of H2SO4. So in one molecule of H2SO4, basically there is two atoms of hydrogen, isn't it? See, two atoms of hydrogen, one atom of sulfur, and four atoms of oxygen. In one molecule, I am saying only one molecule, two atoms of hydrogen, one atom of sulfur, and four atoms of oxygen. So simple, isn't it? And now imagine I have 1 mole molecule of H2SO4. 1 mole is basically what? 6.022 into 10 power 23. So in 1 mole of H2SO4, this atoms will be multiplied by number of moles. Means I can say in one molecule, if there is two atoms of hydrogen in one molecule, then in 1 mole molecule there will be 2 mole of hydrogen, 1 mole of sulfur, and 4 mole of oxygen. Listen again. In one molecule, 2 atoms of hydrogen, 1 atom of sulfur, 4 atom of oxygen. Then in 1 mole it will be 2 mole of hydrogen, 1 mole of sulfur, and 4 mole of oxygen. Okay. Now imagine I have 20 mole of H2SO4. Before it was 1 mole. Now what I have? 20 mole of H2SO4. Then in 20 mole of H2SO4 it will become 40 mole of hydrogen. Means what? In one molecule 2, then in 1 mole 2 mole, then in 20 mole 2 into 20. Simple unitary method. Then it will become 40 mole of hydrogen, 20 mole of sulfur, and 4 into 20, that is 80 mole of oxygen, isn't it? It means what? If I know number of moles, then I can count number of atoms in that particular molecule, total number of atoms. Like for one molecule, 1 mole and 20 mole. Now this 20 mole, imagine rather than 20 mole I have let's say a number, imagine I have 60 mole of H2SO4. okay, I have 60 mole of H2SO4 sulfuric acid. So how many hydrogen? 2 into 60. How many sulfur? 1 into 60. How many oxygen? 4 into 60 moles respectively, isn't it? Just what I did, I simply multiplied number of atoms into mole of molecule, and I can count total number of mole of atom, total number of mole of atom in that molecule. Means how many hydrogen, how many sulfur, how many oxygen. This I can count simply. 60 into 2, that is 120 mole of hydrogen, 60 into 1, that is 60 mole of sulfur, 60 into 4, that is 240 mole of oxygen. After discussing these three cases, I can generalize my statement. And what I can say like after all this observation, okay, I can generalize. See, this number of atoms, that is atomicity, I can say index. Okay, so index into mole of molecule, index into mole of molecule. Imagine hydrogen 2 into 60, sulfur 1 into 60, oxygen 4 into 60. Index into mole of that compound is equal to atom of that particular element, like for hydrogen, for sulfur, and for oxygen. In this way I can count total number of atom. Index into mole of that compound is equal to atom of that element. Suppose I have a compound that is AXBY, so I can say X into mole of AXBY. This will give me total number of atoms of A present in AXBY, any moles, suppose n moles of XBY. So what I did, index into mole of that compound, like X into mole of AXBY is equal to atoms of A. And the same way for B I can do Y into mole of AXBY is equal to atoms of B. So simple. So this way I learned how to count number of atoms, and if I know how to count number of atoms, just simply what I have to do, I have to conserve it on reactant and product side. Okay, so right now this will be clear, I hope so. Okay, let's